Students, in continuation, let's see another example on current electricity. That is resistance of a conductor with varying cross section, right? You know, if the resistance is if the cross section is if it is a uniform wire, then you know R is equal to rho L by A. Yes or no? This formula you already know. But here the cross section is not uniform. The length is L. Some in the starting end here the radius is A and here the radius is B, right? On this side. So what to do for this? We have to find in the figure shows a conductor of length L having cross section. Radius of cross section varies inversely from A to B. Yes or no? From A to B, the radius is varying, right? And the resistivity of the material is let rho. Let the resistivity of the material is rho. Rho is the resistivity of the material. Rho is the resistivity of the material, right? Then, students, and here you see this B minus A. That means the B minus A, the radius of B minus A is very, very less than A. With the uniform, the length is not that much, right? So in this case, we want to find the resistance of this conductor. This starts asking the question, find the resistance of the conductor. Find the resistance of the conductor, right? What we have to do here, students, see, we do one thing. Take a small cross section here as we take. Are you getting? Let that is at a distance x from one end, and let the thickness over here for the small end is dx. Are you getting, student? Getting my point all? We have taken a small cross section, right? Let the radius of that is r. The radius of that is r. Are you getting all? In the conductor, we have assumed a cross sectional area, small cross section at a distance x, and the width is dx, and the radius is r, right? So here, student, what is this radius? How can you find this radius? Let's draw a line here. You can draw a line here, right? Just see, you can draw a line here. This is also L, correct? Yes or no? Center to center distance is L. This distance to this distance is L, right? So student, by similarity, you can see here, just say me, R minus A divided by X, the gap will be equal to B minus A divided by L. We can write this or not from similarity. Just see. This is radius R, this is A, right? This is B, this is A. So R minus A by X is equal to B minus A by L. So from there only you can find radius R, that is equal to how much? Cross multiply, bring to one side, then that will be A plus B minus A by L into X. This is the value of radius, right? And student, resistance of the elemental disk, हमने जो disk यहाँ पर assume किया, let's say we have assumed a disk here, right? Right, resistance of the elemental disk, right here, resistance of the elemental disk, resistance of the elemental disk, right, is how much, students? Let the resistance is small dr, that is rho L by a rho, and the width we have taken small dx length, and the area is pi r square, right? And you can replace the value of r here, so you can write your rho dx on the top divided by pi into what is the value of r, a plus b minus a by l whole into x, right? And the total square, pi r square, right? Getting or not, students? And then to get the total resistance, you have to integrate total resistance of the conductor. Total resistance of the conductor, correct? You have to integrate. That is R is equal to integration of dr, right? That is equal to integration of the dx is varying from 0 to L. If I'll be standing at the left side, it is 0, and at the extreme end, that is L, right? 0 to L. So that is equal to rho dx divided by pi into a plus b minus a by L whole into x square, right? Getting or not, students? Correct? So that is equal to C. that is equal to rho by pi you bring out, right? Dx by something. So you integrate that one, you'll be getting it as 1 by 1 by a plus b minus a by L whole into x, right? Again, that is to be integrated and it will be L by b minus a, correct? And limit is 0 to L. So that R is equal to, finally you will get rho L divided by pi into b minus a, that is equal to 1 by a minus 1 by b, correct? So that is R is equal to rho L by pi a b, right? So this is the answer to the question. Just remember this concept because everywhere it is not required to derive. Rho into L by pi into ab, right? 1 by a minus 1 by b, p minus a is there. So this is the resistance of the conductor. All got, students? Got or not?
Yes, sir.
And sometimes it will be required to find the charge flown due to a time varying current, right? Some of the question that used to come, another concept, just right? Charge flown due to a time varying current, right? Charge flown due to a time varying current. Due to a time varying current, right? Charge flown due to a time varying current. You getting? Yes or no? Student, let's in the question he has given. The current in a wire varies with time in relation I is equal to 4 plus 2t. Yes or no? He's saying the current in a wire varies with time according to the relation I is equal to 4 plus 2t, right? Determine the quantity of charge which has passed through the cross section of the wire during the time 2 second to 6 second, right? You have to find quantity of charge. You have to find what? Quantity of charge during time t is equal to 2 second to t is equal to 6 second, right? Yes or no? Let's see, students. Students, I is equal to how much given? I is equal to dq by dt. Yes or no? That means dq by dt is equal to how much? 4 plus 2t na, students. Correct? You want to find the total charge. Then what do you have to do? dq. You have to integrate dq. You have to integrate dq. That is 0 to total charge q. That is equal to integration of 4 plus 2t, right, into dt. That is 2 to 6. Correct? So that final charge is going to be, finally charge is going to be see here 4t means 4t plus 2t ka integration t square by 2 tt 2 to cancel 4t plus t square 2 to 6, right? So it is 2 6 into 4 24 plus 6 ka square how much 36 minus lower limit 4 into 2 8 plus 2 ka square 4. So that is how much 60 minus 12, that is equal to 48 coulomb. Friends, understood? Just note it down. We'll see a hollow cylinder of specific resistance rho, right? Inner radius r and outer radius 2r and length L, right? What is the net resistance between the inner and the outer surface? What is the net resistance between the inner and the outer resistance? Then simply what do you do? Consider a ring of width dr and radius r, right? Let's consider here in between. In between, you can consider a small ring, right? Getting or not? In between, you can consider a small ring whose radius is let smaller, right? And width is let the width is dr. You have considered a small ring whose width is let this. This is dr, right? So what is the resistance across the ring? Dr is equal to rho into L. L is small dr. It is the width divided by area. Area is small da. So that is equal to rho into dr. What is the length, students? What is the area? What is the area? Length is L, radius is r. So that is 2 pi r into L or not? Yes or no, students? Area.
Yes.
Length into breadth. Length is 2 pi r. Breadth is L, length, right? So net resistance, we have to integrate the radius. Radius is starting from R to 2R because he's asking resistance between the inner surface and the outer surface, right? So that means net resistance, right? Net resistance, that is equal to integration of R to 2R rho delta R divided by 2 pi R into L, correct? That is equal to rho by 2 pi L whole into 1 by L integration is students ln, right? Ln 2. You can write this formula, right? This is the net resistance formula. All got? Understood, students? Another question. There are two concentric spheres of radius A and B, respectively, right? If the space between them is filled with a medium of resistivity rho, then the resistance of the intercap between the two spheres will be how much? Students, in the same way, consider a concentric spherical cell of radius x. It's in the sphere. You consider a concentric spherical cell of radius x. You can write, consider a concentric spherical cell. Consider a concentric spherical cell of radius x. Right? And thickness dx. And thickness dx, right? Then its resistance is, right? Its resistance is dr, that is r is equal to, students, rho by 4 pi into integration of dx by x square, students. Radius is from a to b, right? So rho by 4 pi coming out, 1 by x square integration minus 1 by, well, so only 1 by x, there is higher limit 1 by a minus 1 by b, right? So this is going to be the resistance of the sphere. Just remember the expressions in the exam. The values may be there and you have to just put it off, right? Understood, students? Let's see a hollow copper wire. Another question of inner radius 4 centimeter and outer radius 5 centimeter, right? Now the hollow portion is filled with suitable copper wire. Find the percentage change in its resistance, right? Student, hollow cylinder, inner radius R and outer radius capital R. We have already found its resistance, right? Hollow cylinder, the solution, we can see the resistance is going to be rho L by, do you remember? Pi into r square minus r square, right? Small r square minus outer r square. Correct. So let I initial resistance is how much? Our initial is rho into L divided by pi into 5 square minus 4 square, right? So that is equal to rho L by 9 pi. That is equal to k by 9, correct? Then students, final resistance is going to be how much? Fully filled, na? So rho L by total entire material is total area we have to take by 5 square, correct? So that is equal to rho L by 25 pi. That is k by 25. So percentage change, students. Percentage change is equal to R final minus R initial by R initial into 100, correct? So that is k by 25 minus k by 9 divided by k by 9 into 100. So you'll see it will be around minus 64%. Understood, students? Understood or not? So next, let's see register color codes, right? Right, register color codes. correct? Students, initially there is a table you have to remember. That is BB Roy of Great Britain has a very good wife, right? That means the sequence is there. There is a caller, right? There is a number. There is a multiplier. And there is a tolerance, right? Correct. So here, B for, you can write all the colors. Black, brown, red, orange, yellow, green, blue, violet, gray, white, gold, silver, no color, right? Student, number means for black you can write here 0, for brown 1, red 2, orange 3, yellow 4, green 5, blue 6, violet 7, gray 8, right? White 9. And for gold, there is no value. It's only for tolerance, right? Multiplier is here only into 10 to the power 0. Here 10 to the power 1. Here 10 to the power 2. Here 10 to the power 3. Here into 10 to the power 4. Here into 10 to the 5. Into 10 to the 6. Into 10 to the 7. Right? Into 10 to the 8 also. And here also into 10 to the power 9. And here the tolerance value is 10 to the power minus 1 for gold. And for silver, it is into 10 to the power minus 2, right? And tolerance value is, after multiplier, there is a tolerance value. For gold, it is plus or minus 5%. For gold, it is plus or minus 5%. And for silver, it is plus or minus 10%. And for no color, it is plus or minus 20%. Understood? That means here you can see there will be a register, correct? Here there will be digits. Here there will be colors, right? First color is for digit 1. Digit 1, right? Second color band will be there. That is digit 2. Third band is for multiplier. And fourth band is what? Tolerance. Right? Yes or no? Trying to remember all the colors, you know, BB Roy of Great Britain has a very good wife. Let I'm taking example, you can know directly. Right? Let's take example. You can see. Let's student. First color is given brown. Right? Second color is let given yellow. Third color is let given green. And fourth color is let given gold. So what is the serial number for brown, students? See, for brown, what you have to take 1? Yes or no? So for brown, you will write the first digit 1. For yellow, what is the student? What is 4? You can see the table. Yellow is for 4, right? Then into. For green, what is the multiplier for green, students? Green is 5, so it is 10 to the power 5. So 14 into 10 to the 5 plus or minus gold is tolerance 5%, right? So the resistance is going to be how much, students? 14 into 10 to the power 5 whole into taking common 1 plus or minus 5 by 100 ohm, right? So that is equal to, you can see 1.4 plus or minus 0.07 into 10 to the power 6 ohm. So that you can 10 to the 6 means mega ohm. You can write 1.5 plus or 5 because conversion, sometimes the options are given in conversion, right? So this can be written as mega ohm, correct? So this was for today. Next class we'll see grouping of resistances and equivalent resistances, right? Okay. Next class we'll see what are the resistances in series and resistances in parallel and various circuits we'll see in the next class, correct? This was for today. Bye.